Chapter 2, Static Routing, Implementing Static Routes. Routers learn remote networks in two ways. On the left side, we see static route. So R1 will enter the remote networks of R2. R2 will enter the remote networks of R1. So that's a manually inputting the routes and a very simple topology. In this topology on the right, we're using dynamic routing, which is EIGRP. And R1 will share its networks across the link to R2. R2 will share its directly connected networks across the link to R1. Therefore, letting the routing protocol make decisions. So why are we using static routing? So if you look at configuration complexity, dynamic generally depends on the network size. Static routing, every time another entry is entered, it makes the network grow in size. Topology changes. Dynamic automatically adjusts the topology changes. So if routes go up or down or links IP changes, it'll automatically send updates to the other routers involved. Static routing administrator must intervene and change all the static routes that were affected by the change. Scaling. Dynamic is suitable for simple and complex topologies. Static is only suitable for simple. Dynamic is less secure because it shares information across the link, and static is more secure because it does not share any information. Resource usage. Dynamic uses more CPU, more memory, and more bandwidth by sharing information across the link and also calculating the best path with the routing protocol for dynamic creates more usage on the CPU, where static routing, it's manually inputted, no decision making has to be done by the actual router. Predictability. So dynamic routing, because it's always adapting to the topology changes, will be very predictable. And if not, it would be a short period of time before it does become predictable. And for static routing, the route to destination is always the same. So if any changes occur in a topology, the administrator must get involved. When do we use static routes? For small networks not expected to grow, R1 is a stub network. You have one way in, one way out. And you can use a single default route with quad zeros, IP route quad 0, either local interface or next hop address. And that will be a default route to R2 who's connected to the internet, and R2 will be able to get your information from R1 to the internet. Static route applications connect to a specific network, connect to a stub network, summarize routing tables, which reduces the routing advertisements in the lookup process, and also creating a backup route in case the primary fails. R2 is configured with a standard static route to the remote network of R1's 172.16.3.0. So it's IP route, network, subnet mask, local interface, or the next IP address of the next router. Default static route. They can be dynamically learned or configured. You can use the static route IP route quad 0 in R1 to reach R2. So IP route quad 0 means send all traffic out local interface or to the next hop address. It also creates a gateway of last resort, and a lot of ISP companies use it on their edge router. It's very common for most of our homes to have just an IP route in our home router to the ISP company. Summary static route is usually, like we said, for large networks, and we can see that 172.20 with a bit mask of 16. So these are all separate networks, but we want to summarize those for the routing lookup to pass on to other routers. So send the common bit pattern. We'll learn how to do the bit pattern later of 172.20.00.14. So it summarizes all those routes down into a single route, which is common to all of them. And your floating static route is going to be your backup when your primary fails. So branch wants to use the preferred private WAN. If that goes down, then we're going to use the backup route number 2. Remember, administrative distance is the trustworthiness of the route, and so closest to 0 is the best. Directly connected networks are 0 for administrative distance. Static routes are 1, and then your egrip is a 90. So currently, the static route looks more attractive than the primary route. So what we're going to do is change administrative distance on the static route, on the second route, to be 91, making egrip look more attractive, more trustworthy than 91 of the static route.